So, welcome to the first ever software maintenance course. The furniture arrangements on this classroom were a bit of a surprise for me also, so sorry about that. Try to come up with some arrangements so that you can actually see me and this board here. You obviously noticed that these chairs have wheels underneath them, so you can just change the places a bit if you want to. Don't want to break your neck on watching this presentation. So anyway, the agenda today is more or less that. Obviously, I'm going to give you a speech about how to pass this course, how to get a successful grade on it, what you are actually expected to do, and finally, start with some ideas on what we are actually doing on this software maintenance course and why does this course actually exist. So, without further ado, let's start with the agenda today. So, as I mentioned, this course is software maintenance course. If you were looking for something else, you might want to leave now because you are in a wrong classroom. Anyway, my name is Professor Jussi Kasurinen. Some of you may know me already from the fundamentals of game development, or if you are taking these courses completely out of schedule, from operating systems and system programming, or from some earlier courses which I gave a couple of years ago. But nevertheless, I am the only person assigned to this course this year. So it's really easy and convenient for you to know that if you have problems with these assignments or these courses, you just ask me about these problems. There is no course exercises or course assistant because we are going towards the online environment. So every exercise, every project work, so on and so on is submitted to Moodle, and provided that these recordings actually work, also these videos will be available online. Of course, it's a bit of a boring thing to record a lecture to an empty classroom. Because I'm paid to do that, I will give the lecture even to an empty classroom. I have actually given lectures to empty classrooms in history to make a complete set of lectures. But anyway, if you have nothing else to do, you might also become here, and also after these lectures, which usually don't take the entire 2 hours, are not intended to take the full 2 hours, you can also ask about the project works and assignments and these sort of things, because this is the only face-to-face teaching event of this course. So, the course contents, this is, I guess, from the study guide. But the idea is that actually on all the previous courses you have been taking as a bachelor or master of software engineering, we have been talking about developing software, whether it's games, mobile applications, back-end, front-end, whatever. We have been talking about the situation where you are developing the software or the service. On this course, the idea is that we already have an existing product, whether it's a service or a website, an application, whatever it is. Nevertheless, it already exists, so we have to maintain it. We have to update it, we have to upkeep it, we have to fix it, we have to transfer it to new platforms, these sort of things, which actually are more or less the usual thing that the programmers do in the industry. There's product families, which are more or less just upgrades from the previous versions, and the first version of the software or the first version of the product was developed somewhere in the 90s, 80s, and you have to just maintain it or keep the system working, in a sense that you have to transfer it or the ideas of the software to new platform, new technology, while maintaining the user interface similarities or ensuring that everything still works as it was. No one likes a broken patch. or broken fix, because it's just absurdly expensive to keep fixing things, especially if you are fixing your own fixes. Anyway, so how to produce, use reusable software? What is software evolution, maintenance evolution in the life cycle of the software product, and so on and so on. I know that you have been talked about these things, for example, in the fundamentals of software engineering, or software engineering methods, or whatever the name the course now has. I think it's models and methods and modeling or something like that right now, and it just ended. But basically, this extends on the part that was more or less just skipped over on that course. So basically, the idea is that you are taught a list of techniques, tools, and methods which help you to understand or maintain, fix, update, and so on existing software, or add features to things that already exist. So this more or less is the list of lecture topics. You might also observe that there's only 10 lectures here, and there's 14 weeks of the course. That's because the last 3 weeks here are meant for a visiting lecturer from the industry and seminar presentations by you, which I'll get back to in a couple of minutes. And then there's also the summary lecture, summarizing everything we have been doing so far. So basically, on the first 10 weeks, we will be talking about different things, different aspects of software maintenance, things that are most probably not mentioned or not discussed to a very detailed degree on the earlier software engineering courses. Of course, if you are a transfer student from somewhere else, I have no idea what you have been taught on the bachelor's degree program, but let's go with the assumption that you took the LUT bachelor's degree. So these are things that are somewhat new to you, hopefully, I guess. Anyway, the course has 2 project works and a seminar presentation and an online exam and mandatory weekly assignments. So we are doing things on this course. These the weekly assignments are really just something to ensure that you actually understood what was discussed on the lectures, or are proficient to use the tools which were introduced on the same lecture. But the more interesting things are the project work, the project works, and the seminar presentation, which ensure that you actually understand and are capable of doing real maintenance work on real software. Of course, because I'm not selling you to slavery for Microsoft or something like that, we will be using open source projects here, but still they are on the size and scale and complexity and with the broken old unupdated tools and patches and broken modules, more or less the same things that you would probably encounter when you were doing maintenance work on real software. So anyway, the visiting lecturer will be here during April, and the schedule now is that the visitor will be here when you are expected to be doing your seminar presentations and the final report for this course. So it's some reason to keep for you to come here and listen what the actual industry people are doing. If we cannot book a good presenter there, we will probably just leave it out this year, or I will link you something from YouTube, which I guess is fairly popular thing to do, because there's tech talks and stuff like that. But I'd like to have a real representative here from whom you can ask actual real questions. Anyway, there's a couple of books and other materials, especially on the software maintenance. The April and Abram book is, well, it's a book. It's an American textbook on software maintenance and software maintenance management. So you can guess that it's 800 pages and costs really a lot of money. So it's not something I'm expecting you to buy or get or use, it's a book that more or less covers all the topics of this course. So if you happen to come by it cheaply, for example, the last edition from places like Amazon.de, which, by the way, sells used college course books, or by library or somewhere else, you might want to look into it. But it's no way necessary to actually own that book for this course. Everything will be in slides or presentations or somewhere else. There's also software engineering standard, the ISO IEC 14764, which is fairly bare bones model explaining all these things we are talking on this course. This material will be available to you on the Moodle pages, and other things I'm throwing there as a further readings is probably something that you might want to look into if you are interested in these things or want to actually get an idea on what other places are talking about in software maintenance or software engineering aspects. Anyway, the workload is as follows. On this first period of the spring, period 3, you are expected to participate on the lectures and do the homework assignments, which will be given you via Moodle pages. These are technical essays and small programming tasks and stuff like that. And on the period 4, you are still expected to participate on the lectures, do the homework assignments, and do the project assignments, including giving the presentations. Of course, the end-loaded workload usually doesn't work that well, so since the course projects are already online, if you go to the Moodle pages of this course, you see that they are both already available. I'd say that you probably should get at least the first one started when you think so, or when you have time to actually start doing. So anyway, the course grading, this time we are trying something a bit different. As you can see, the online exam is actually only 1/5 of the points on this course. So it's not like it's 2 mandatory projects and an exam which dictates everything. We are giving points on all these different things on this course. The individual weekly assignments, well, you are required to do a number of them anyway, but if you are doing most of them, or at least on an acceptable level, you will be given points for the final grade. If you do the teamwork project well, it will give you more points. There's a detailed explanation on how that thing is graded. If you take an online exam and ace it, you will get the 6 points. And the final project, which includes the project presentation itself, the technical work, and the report, is actually 12 points, and it's the most important thing on this course. Of course, keep in mind that since you are allowed to work in groups of up to 3 students, the assignment sizes have been considered so that you probably should at least have a partner or 3-person group. But it scales a bit, but the amount of documentation and stuff is actually still quite much if you prefer to do it individually. But knowing software engineering students, I still allow you to work alone because teamwork sucks ass and so on and so on. So of course I'm not going to try to enforce you to be social with the other peers in your student group. Just work alone if you really want to. Anyway, you are required to get at least 1 point from each category. Of course, you will not pass the course that way because you didn't get at least 14 points from the course, but at least if you have 1 point from each category, then you are eligible for final grade. So, what are these 4 things? First of all, the weekly assignments. Well, the course weeks 2 to 10, so starting next week till the end of the lectures, you will be given 2 assignments per week. In average 2 assignments per week. So, but you only have to complete 1 of them. So it's usually practical coding tasks for people who are proficient programmers, or it's about theoretical reading task where you have to come up with a technical essay explaining to me or explaining some concept which was also discussed to some degree on the lectures. Select which one you prefer to do and submit that.
Both of them?
No, because it would be too much work.
Okay.
So on the probably on the last week or second to last week, I'm going to perhaps allow completing the both assignments. But let's start with the one assignment per week.
Okay.
Because it means that you only have to focus on one thing, and usually it means that if I give you too much work, you will just drop the course, and it's also not a good thing to happen. So anyway, select the one which you prefer to do and submit that. And that's your weekly assignment. And the amount of assignments you have turned in, so the maximum amount is 9 assignments. It directly translates to the amount of points you get from the weekly assignments. It's not really a rocket science, but hey, I have to say this out loud so that no one can argue that I didn't explain this to you in the lectures. Anyway, you have to turn in 4 works to get the 1 point which is required. So for the next 5 weeks you will actually have to do something on this course, or the last 4 weeks. Well, but I'd say that you probably should start earlier. Anyway, the deadline for these lecture things, always unless otherwise mentioned, is that it's before the next lecture. So usually when I come here on Monday morning, I'll put this week's assignment online, maybe say a couple of words about it at the end of the lecture, and then you have the entire week time to do and finalize your work. But we are not having this one this week yet, because I know that the first week is always a hassle when the courses are starting, so we are not having the weekly assignment on the first week of the course. There's also another thing about these weekly exercise groups and assignments. If you go to uni, it lists some randomly generated number of exercise events, usually taking place on Friday in Linux classrooms. These are leftovers from the previous lecturer who was meant to give this course this year. So because I decided to go to a more online friendly approach, these are, well, scrapped. There's no separate exercise event on Friday afternoon. I'm sorry about that. You really have to go home or do something else. So, anyway, the Linux classroom is reserved for this course at these times. So if you want to have a meeting with your group or do some test sessions for the projects and exercises and stuff, you can go there to the Linux classroom at that point, but keep in mind that I will not be there. So you just have to, you can do the work home or you can use the Linux classroom. So to be completely clear and precise on this, there are no separate exercise events on this course. So if you are participating online from some other place, well, most of you probably aren't, but the people who are listening this recording after this lecture might be, then there's no reason to come here for the exercises. Everything is distributed and submitted online, and you can ask questions from the discussion board, which will be added to the Moodle pages, or by visiting me at consulting hour or asking questions after the lecture. If you do not live in Lappeenranta and the Moodle discussion forum doesn't actually work, then you can just send me an email if you find a problem with the assignment or some technical detail which simply doesn't work. But keep in mind, these exercise groups don't exist. They are in uni, but they are not given. Also, going into the actual things that we do have on this course is the teamwork project. This is the first project of this course. So this is a technical challenge which requires your team, you to create your own team, first of all, and you to do some software development and documentation work. So your team is given a project source code. You need to build up a repository for maintaining and updating that project. Also select the tools and stuff and other things so that you can actually do development work and quality assurance work and these sort of things So you probably should read the documentation through and try to find out what sort of things this project has been using before. So this year, this first assignment is done with the open source strategy game 0AD. I don't require you to play the game or even like the game if you don't like video games or something like that. But I am requiring you to find out about the product, how it's made, with what tools it's made, how it's supported, and so on and so on, and create or design an infrastructure you would use if you were tasked to maintain or develop that product further as a professional developer. There's also bonus points for actually doing some development work on your copy of the product, or doing testing work on it, finding and fixing bugs, or making a sophisticated framework like allowing automated testing or stuff like that. But the entire assignment is already online, so you should, after this lecture, go there to the Moodle pages and read through that assignment. And also keep in mind that you can have a team of up to 3 students, but you will be using that same team for all the seminar presentations and both of projects. So you probably should consider, are we capable of actually completing these assignments? This is also why they are already online, so you can form a team which actually should probably have someone who can do programming work. Just an idea, but hey, keep that in mind when you are selecting your group of people. Anyway, this teaches the concepts and tools which will be used in the seminar project. It also gives you an idea on what the maintenance work will probably be like if you are doing it as an actual real job. So this is why we are doing it. The online exam, well, there's really nothing interesting in that. It's a Moodle exam. You can take it home, or you can come to university, whatever. But it will be open on Moodle pages. It will have a number of randomly selected questions from the pool of similarly difficult questions, and you will have 3 hours to complete the essays and other things during one day. So you can also use whatever sources at your disposal. You can use internet, you can do whatever, but you have to reference everything you were using to answer those questions. So this isn't exactly very difficult. If you took the operating systems and systems programming course last fall, probably didn't, but still, if you took, that's the exactly same thing. So you can do this wherever you want to. You have a 12-hour window to do it, to complete it, and you can use whatever resources. And because I'm going to make a sufficient pool of questions, I don't care if all of you here today go to some classroom or workstation classroom to complete this exam together, because the statistics will say that you will not be doing the same exam. Probably there will be no 2 students who will be doing the same exam. So there's that. Also, but keep in mind that this is only like 20% of the grade. So this is something that we are doing, but to ensure that you actually understood or listened to the lecture recordings. But still. Finally, this is the actual project which nets you most points, almost half of the points from this course. So this is an examination of how one real-life software application is maintained. So you will be working on the same group as with the 0AD teamwork project, but now you are allowed to select one open source application, operating system, or game, well, open source game, whatever fits your interests as a group. You are expected to conduct a study on how this project is maintained, with what tools, with what quality assurance or quality control methods, programs, approaches. What are the most common problems with this project? What are the most common activities that the developers have to do now that they are actually maintaining the software, and what aspects could be improved based on what you heard on these lectures or based on what you saw when you did an investigative analysis on the open source project. And based on the information, do something similar than with the first teamwork project. So recreate the infrastructure needed to do maintenance and quality assurance work for this project, and make a number of proof of concept additions, meaning that develop a number of new features with your tools on top of this open source application or game or operating system. So then you are expected to write a report and make a seminar presentation on how this software is actually maintained, what are the problems, what sort of things we saw, how the quality assurance works, how the quality control works. If I were to add a feature to this product, what would we have to do? What are the most important issues? What sort of things happen when someone adds a feature, and so on and so on and so on. But please keep in mind that I want to keep this sort of interesting in a sense that we are allowing only one group per application or operating system or game or whatever open source project. So first come, first serve. Go to Moodle pages and see the instructions there. You can, if you register your group, or when you register your group, you are also expected to tell what open source project you are selecting for your investigation. And if you are trying to reserve something that some other person took earlier, or some team took earlier, then I'm going to have to inform you that you have to select something else. The most recent list is on the Moodle pages, and the reservation order is the timestamp of arriving email on my email account. If some of you manages to send an exactly same project on the exactly same second, which I really doubt, but then I will be flipping a coin, but that's really not a realistic problem here. Anyway, and of course 0AD is not available for the final project because you already did some of this work earlier on the teamwork or team forming project. There's also some additional things you have to check before you reserve anything, like is there actually data available, is there actually information available, and these sort of things, because it's up to you to dig out the information required for the seminar, for the presentations. If you go if you go with something that you selected by yourself, it's up to you to ensure that there is actually information to do the analysis with. So check that before you reserve anything. Anyway, everything is on the Moodle pages. All the course-related information, detailed instructions, announcements, so on and so on, will be first made at the Moodle pages. If it's something that's announced on the lectures, then it will be also announced on the Moodle pages more or less immediately before or immediately after the lecture. And this is also the place where you should submit everything on this course. Because there's something like 60 of you on this course, and there's weekly assignments, a couple of projects, and so on. It means that if I allow email submissions or email help or something like that, I will not be able to actually notice everything. So email submissions will not be opened or reviewed. So what I'm trying to say here is that especially if you are a late enroller, please ensure that you have access to the Moodle pages. If you enrolled in time, you probably should have, or someone at the Student Affairs Office didn't do the job properly. But if you late enrolled or have not enrolled yet, then ensure that you also get access to the Moodle pages. If not, go complain to the Student Affairs Office, or if they don't want to help you, then send me an email. And finally, some legalese. this isn't actually even close to the last slide, but still some legalese on this course. So this course requires programming knowledge. If you cannot do programming tasks with any programming language whatsoever, you probably should go and take a couple of programming courses before you attend this course. However, you can decide what tools and languages you want to use. So there's not really strict requirement of something like Java or C++ or something like that. If you are capable of programming with something, you probably are capable of at least learning enough to complete all the assignments on this course. This course may have difficult assignments because we are trying to get as close to as real maintenance work in the industry is. So there are assignments which are complex, difficult to do, may require actually very much work. So this also means that if you do the usual way of doing things, skipping the first 6 weeks of the course and then starting at the latter parts of the fourth period to get a passing grade of 1, because 1 is enough, then you will probably be screwed, because these assignments are increasing in difficulty. I am allowing teamwork, and I'm actually even allowing that teams help each other. Of course, it's just reasonable thing to do. Even in the industry where people are working with the non-disclosure agreements and stuff like that, people are still talking on the smoke break or coffee break or lunch cafeterias or places like that. So of course you can help each other out. That's not a problem. But if there's a possibility that your solution is too close to someone else's, you might want to mention this on your documentation. I don't want to start an academic disciplinary action because you didn't mention that, hey, I helped these guys. Anyway, it is cheating to copy or buy your exercise or project works from the internet, from a colleague, other team, or anywhere else. Every team and every student has to make their own original contributions, and all the students or members of a team which are caught cheating will be kicked out of the course and reported to the faculty. And I cannot make any exceptions on this one. So you are allowed to use internet sources, you are allowed to help each other, you are allowed to select whatever works, but as long as it's referenced. Keep this in mind. This actually means that something else, in practical terms, it means that if you are struggling with a programming problem, places like Stack Overflow have usually something at least similar which you might want to use. So you might want to reference those places if you are copy-pasting their explanations or solutions to your work. Anyway, all requests, questions, comments, and stuff like that, hate mail should be sent to me, and I will answer to your problems or questions, or if there's a broken exercise assignment or something that's simply not possible to do, send me an email, or you can visit my consulting hour on Wednesdays from 1 to 2. I'm still right now at the 6th floor of the 7th building, but this will probably change before this course ends, because I just heard that we, as a Lens, are moving into one building, so the new room and place will be announced when I know that. Good. So, before we go to the actual content part of this lecture, does anyone have any questions right now? Good. This is the one part I like. When I allow you to actually ask something, no one ever says anything, because no one is dorky enough to actually ask something and keep the lecture going on. Anyway, so software maintenance in general. You have been talked about software engineering, software processes, this sort of stuff. What's problematic or what is difficult in software development? So why are we having yet another course on software maintenance? Well, first of all, the maintenance here isn't exactly like it would be something with a car or a chair or building or whatever. So there's a couple of definitions here, but with the software there's actually an interesting addition with the maintenance work, meaning that it's not just that we keep things fixed. It's also about adding new features or making the product work on a new platform or new technology, or adjust the product so that it actually works with the new user group or new customer or these sort of things. For example, if you sell a ticket sales machine or something that manages a web store or stuff like that, and you have to add your new customers' logos there or do customization work and these sort of things, this is also maintenance. So it's not maintenance in a sense that you are changing oils and some broken parts from the engine. It's maintenance in a sense that you are modifying the product to fit some new customer. And of course, with this, the maintainability, which was sort of a marketing word for things, actually means that how easy it is to make these changes or adapt new features or add new features or add new content or make changes for the new customers and these sort of things. How is the product designed so that it actually can be maintained, because that's actually really important. And of course, because we are talking about software engineering, we are talking about things that happen with people, with technology and tools and processes, and well, sometimes the problem is that there is no process, but there's also problems here. This isn't exactly rocket science, this is the same stuff that you encountered already in software engineering. So the programs which we maintain may not be well documented. Fix after fix after fix after fix. Who knows what is the latest version? Go check the source code. That's where the documentation lies, or doesn't, depending if the company actually bothers to make systematic maintenance work. The programs are or become unstructured, so sort of everything affects everything. There's a high level of coupling and low level of cohesion. So that means that if you are trying to fix one thing, everything collapses. That's also a problem. And also that the program doesn't use the data models, or it has sort of hot fixes or workarounds for things that should be codified on some systematic way. So basically what it means that the maintenance becomes a problem if the system isn't designed for maintenance in the first place. So if we are making crappy code, we will make a crappy software which is a complete nightmare to maintain or fix or adapt to new usage. And of course, writing a crappy code is a age-honored tradition of turning in university assignments, but still, if you are working with real software product, you might still be using the same source code after 10 years or even longer. For example, some C libraries, I think, are already on the retirement age of 60-something, so keep that in mind. So, if we are talking about why the maintenance is hard, well, usually if we can't trace the product or the process that created these things, it's going to be a problem. Like with the development step earlier. If we don't know who made this, or we don't know who understands this, or we don't know where we can find more details about this, it's going to be a nightmare. Also, if we are tracing some bug or feature or functionality and we can't find where these things actually happen, or if they are on two separate places and randomly we use the one instance and randomly we use the another, then we are also going to run into problems. Of course, this also means that there's no documentation which works. There's a lack of change stability, so the system might do something a bit crazy, it no longer stays functional. So basically, there's a number of things which we might say that why the maintenance is hard. So basically, all these things are people being lazy or taking shortcuts, but that's not necessarily true. If we use software, we will have to make modifications to that software, and when we do modifications to that software, it means that all the support materials and all the internal logistics of the software actually will change. So we also have to maintain or write down or document what the new version of the software is doing. And of course that takes time, and if we are talking about something which has really hectic cycle of delivering patches or content or stuff, doing some continuous integration or continuous deployment models, for example, it means that this becomes a problem because the ripple effect means that if we are no longer certain that everything works as it works, we can't rely or trust any of the modules, then we obviously are going to run into problems because we would have to check the entire system every time we are trying to do small modifications or changes. So these are the things why we need to think about maintainability. And this is also why the previous slide said that if we don't design the product to be maintainable, then it's not maintainable. So this is the slide you probably already saw in the software engineering methods and models, so I'm not going to spend too much time on this thing. So what is a software? Software, in an older sense, is a compilation of different components or modules which do something. They manage things and then they send messages to each other, ensuring that something actually happens. They request operating system to open them files or read them, some internet sockets or whatever, but still it's a network of components or modules sending messages to each other and doing stuff like drawing a guy or user interface, using network and harassing the graphics card to draw you a new stuff or do calculations and stuff like that. So inside each module we have objects, which are more or less the things that you write with source code on object-oriented languages. Exactly these things, but they do routines and they manage messages. Of course, there's hundreds of them in almost every reasonable software, so you really have no idea what each object in each module and each component is doing. The amount of functional lines of code actually is easily hundreds of thousands of lines of code if we include everything from the standard library which the linking and compiling system adds to your software. Even if you are doing something simple like Hello World application, it probably has 10,000 lines of code if we include all the machine instructions which are included in the final compiled usable software. So it's not only the problem that we probably don't know what the system is, what the software is doing, but if we add the entire system here, which includes the databases, the backend, the other system, internet connections, keyboards, touch screens, gamepads, operating systems, virtual and execution environments, these sort of things, standard libraries, extended libraries. It actually means that there's no way to actually know what happens everywhere. And the system is the connection of all that is needed to make the software work. And actually, if we talk about the software engineering methods and models course, this, or at least the older one, I actually don't know what, I'm not certain what you talked about on the this fall's course. But earlier, the software engineering methods course considered the acceptance testing of the high point of everything that you need to do as a software developer. So you have the system being built here. You have this, all the components which are actually working, the client-side stuff, the server-side stuff, the sensors, inputs, controllers, everything works. So now you have a perfect software product here. It might even have been delivered on time, in budget, with the features and acceptable quality. So you had a successful software development project. And everything works now. So that's great, but unfortunately, that everything is going to be worse from now on. So now you have to maintain this stuff, or have to ensure that your customers, your users, can still use the stuff when they buy new computers, or there's new additions or upgrades, or things happen, or if your database completely falls apart, or like with the Netflix, which actually had to switch around their entire system infrastructure or architecture to container-based approach, simply because they grew so big that they couldn't handle everything with their old system. So this means that the acceptance testing phase is probably the place where you have the least amount of problems with the software, and the first problems caused by the customers or users are about to hit your bug tracing tool. So this means, of course, that the software lifecycle looks like something like this. Of course, it's really simplified and old school thinking. It looks like almost a waterfall, but it's on the form of snake. Also, there's one arrow, meaning that the design, development, and quality assurance here are trying to play some iteration game. But nevertheless, don't focus on that. But the general idea is that we gather requirements. We understand what we would want to do and what would be the customers. We specify what sort of things we need to do. We do the design work so that we can develop things which we have to test, and if it doesn't work, we have to redesign things, and so on and so on. And at some point, we go to acceptance testing and start operations, meaning that the app goes live, or you deliver your work to customer, your operating system or open source application is now available for people to download and try out, and these sort of things. So, but what is actually interesting here is that now we have to do the upkeep, the maintenance part, which sometimes might be 95% of the lifetime of the entire product. Also, at some point, we will have to make a decision that this is too old, this is unmaintainable. We have to end the support for the software. We have to make a completely new version of it, or we simply have to abandon this product. But the important aspect to understand here is that we have been talking about this part quite much. And this is what we call software process, usually. But in this course, we actually have to look into the larger, bigger picture here. Meaning that we are talking about the entire life cycle of the software. So we are not doing something with the months or weeks or even daily iterations on some things like test-driven development or extreme programming or something, stuff like that. We are talking about years here, sort of eons in the computer science or software engineering industry. For example, database solutions or stuff like that, which were made in the 70s and are still used, or even something simpler like Windows 3.1, which probably is the first operating system you have seen when you were toddlers, but it's still used. That's a piece of software, it still exists. It's actually fairly popular in the cash registers and these sort of things, which require graphical user interface but don't require any or many computing power things, or don't require that much security because they are always closed systems. So it means that even if you are already over the Windows 3.1 and DOS era, but you might still have to maintain it, or someone is still paid to maintain that software, and it still hasn't died, and there still is point of sale systems developed on top of that environment. So basically, if you took the software engineering methods and models course, which ended just before Christmas, then this is the rough division of this course, that course and this course. So we are trying to stay here on this side of the life cycle, but obviously we also have to talk about maintainability and testability and quality control and these sort of things, so we sometimes might actually dabble on this part of the process. Anyway, these are more or less propaganda for me, with which I'm trying to tell you that even if this might seem something that's obvious, very obvious, this is also something that you really should pay attention to, because you are training or you are reading yourselves to become a master of software engineering. So obviously we can't catch all problems. There might be still things which we detect only after validation and acceptance. So even if we don't have any users for anything, we still have to do maintenance work, even on our own computing scripts or applications or web crawlers or things that analyze different data sets or stuff like that. It's a thing that happens. And of course, if we all know that if we have to edit or modify something we made a long time ago, it's completely alien. Even if we knew exactly what everything is doing when we were developing the software, we might have problems understanding what we were doing if we are maintaining the code we were after a long period of time, so that we don't that you don't actually remember each detail anymore. And it only gets worse if you are trying to maintain someone else's work. And of course, because operating systems, database systems, data management systems, clouds, whatever, keep becoming better and better, more complicated, more complex, you also have to maintain or upgrade your software for those platforms, even if you, especially if you are doing something commercial, like most of you will be doing when you graduate, or if you are like most of the software engineering students 2 years before you graduate, because you find a summer job and you never leave that place. You just make an university studies your hobby or something like that. Anyway, so the thing to understand here is that the software maintenance is usually it's a significant portion of all the costs related to one software. There is some tools, methods, techniques which are used in software maintenance itself, but actually it's surprisingly close to doing normal software development. And whatever the technology, technique, or tool used to create the software, you will have to do maintenance work at it on some times. So there's a rule of thumb here, which isn't, of course, it's not true on everything, but it gives you an idea on the scales of the costs, especially if you are interested in running a software company or thinking about launching a game or application or something like that. How much effort and money you have to use. So usually, to coming up with an idea and proof of concept for something that might be a viable commercial product, it costs €1, or well, takes 1 month out of your time to develop. This means that it's a proof of concept that actually has the finesse of attracting someone paying you for developing it as a full product, or you can find someone who is foolish enough to make you a partner and found a company which makes the product. So next, it costs €10 against the one spent in design to develop the product from that idea. Meaning that it's a full-fledged product, sold, well, on every venue that's appropriate for the product. But finally, it actually becomes a problem when you launch the product itself. And you got 10 euros, and you have already spent 11 euros, but it still costs 100 euros to maintain and commercially support the product through its life cycle. So unless you are really into doing charity work, you probably should come up with something that gains you revenue, gives you money, funds to do the maintenance work, because that's the expensive part. The development work usually means that you are just paid to deliver the product, and then there's a separate fees for doing maintenance work. This is also something that many companies which are working with university fail to realize, that we might create something for them as a part of a project or research work or research cooperation, or as a master's thesis work if you are doing something for a real company later. But it's not the costly part. The costly part is actually using that software and keeping it relevant and ensuring that it actually works. It doesn't mean necessarily much. It's just that every time there's an upgrade to something, you just have to check that it still works. So probably that means that you will have to keep at least one developer or yourself occupied every now and then, and it actually starts to pile up when the weeks and months keep going. So, of course, this might be a problem if your marketing director is stupid enough to allow deals where you are not paid to do maintenance work. You probably should fire that marketing director or find a new job anyway. But still, of course, this is a strategy in some software industries. For example, all free-to-play games, more or less, do development after launch. You can select almost any of them, and you constantly get content upgrades or balancing fixes or something like that. The Linux environments, the Windows environment, the Mac OS environment constantly gets new upgrades and stuff like that. So, but especially in the games industry, because you are giving away the product for free, it actually means that these two steps here give those companies absolutely nothing. They are making their money in the maintenance work. Also, it's a bit rude to say, but also many software companies which deliver traditional software, for example, to the government, also do this. They bid low when they are requested to do create a software for some government faculty or facility or something like that, and then they completely rip them off with the maintenance costs. That's how the business works. But that's just the business part of it. Anyway, there's also the other problem, which I tried to emphasize on the first part of the lecture. Even though this is a problem, the maintenance or maintainability is a problem, there's actually surprisingly low effort on actually understanding what needs to be done on the maintenance and before the maintenance, or ensure that the software or the product or app or whatever you are developing is actually maintainable. So if you consider even simple things like making a Google search, if you search for software process or software development, you hit huge number of things. If you Google stuff like software maintenance or maintainability or stuff like that, there's something, but it's really not that much. So even though this is an actually really important part or important step of the software lifecycle, it's not actually that well mapped or well understood or well designed, or at least it's not taught very well. So that's why we also added this software maintenance course. So, of course, there's the standardization model. Of course, the first thing you obviously notice here is that it's international standardization, this attractive graphical presentation of the software process immediately tells you that this is a software ISO IEC standardization, which states the obvious, so to say, and these sort of things. But this is actually, well, this is more or less the way it explains things happen. So we find some problem, we analyze the problem, we implement the modification, we review or see that it actually works, and then we migrate to the new system or commit to the fix, or we retire the software, because it's always a possibility that this simply doesn't work individually. Of course, I'm not going to go into detail about this at this point, but still, this is more or less the important part here to understand is that the maintenance maintenance development process cycles aren't really that different from actually developing the software. It's like a series of mini projects after the actual delivery. Also, if you are doing something like continuous integration or continuous development, it is actually completely the same or the same thing that you were doing in the initial development phase. You will just at some point hit a point where you have enough features and enough content and enough technical stability and product which is feasible for launch, and then you just keep developing it like it never actually was put available online in the first place. So there's a couple of different things we want to achieve with the maintenance. These are just high-level classifications trying to explain that not everything is always the same. So we do corrective maintenance. We try to fix the errors. We do emergency maintenance, which is the bubblegum fixes to keep the thing running with no money and no budget. We do adaptive maintenance, so we try to keep the hard system compatible with the hardware and software, and we do perfective maintenance and additive maintenance to increase the amount of content or make it more attractive or usable for the customers or people who pay for us to deliver the product. And there's also preventative maintenance, which increases the system's maintainability and makes it a bit easier to do the maintenance work in the future. Of course, like with everything else, preparing for problems isn't really a thing in software engineering and computer science, or in software business in general. So the preventative things, making things more easier to fix in the future, is non-existent part. But the perfective, meaning adding more content, is actually the most common type of maintenance work to do. So we are tailoring the software or making modifications, making the user interface easier to use, adding support for more languages, these sort of things, which are more or less the most common things to do. And the corrective and adaptive things are more or less the same. So consider that you probably have to do, if you have to do maintenance work, there's a good probability that you are doing something to fix the user interface or fix the user annoyance problems, the hygiene factors, which I think might still be explained on the fundamentals of programming course. And also, if we are talking about software, we also have to take into the software lifecycle. We also have to take into account that the programs actually age. Because the technology moves forwards, there's usually also emphasis on different things on different stages of the software. There's a number of dinosaur things which stay. They are usually related to Unix basics and stuff like that. But still, most of the software go through the maintenance phases. So at the first stage, we try to emphasize the user support, meaning that we are trying to get as many people to be able to use the software as possible and try to keep fix the annoyances and small things that drive the users away. Then we try to correct the faults because we are having more users, we are finding more problems and more things which are broken with our product. On the maturity phase, we do enchantments, meaning that we add features or nice to have things which we didn't want to do on the original delivery, or we didn't have money, or we are trying to desperately attract more people to use our software, so we add new features and do stuff like that. This is also many times the point of bloat. If we are talking about software bloating, it means that we just add features and stuff to the system to the point it completely breaks down. It also means that it loses performance and stuff like that. And finally, we on the decline phase, we try to keep the system functional with the current hardware or current software system or current operating systems and these sort of things. So obviously the programs gain age, and depending on the age we have to emphasize on different things the maintenance work. Trying to keep it alive, trying to add more features that the competition has, trying to fix the actual problems, or trying to gain enough users or attract enough users to actually use the software and make it able to live. So, well, there's a couple of things listed by this Van Vliet study on maintenance, and the unstructured code, insufficient domain knowledge, and insufficient documentation, surprisingly, are the most common maintainability issues. So if you wonder why you were almost to the point of religion talked about the coding conventions and documentation conventions and these sort of things, they both are things that are realized here. The coding conventions are used to ensure that everyone can understand the structure of the program code or the source code of the system. The documentation practices are ensured that there is documentation, and the domain knowledge is something that, because people keep changing, no one knows what the original system did, or because if it's in support, no one might have an idea on why things were made this way. No one no longer is using the software as it was intended to use, so they have only a vague idea what it should be doing. So, well, there's a couple of tools here. We will be going through these things and what we can do with these on the separate lectures. Reformatters, create insight on structures, get insight on dynamic behavior, inspect the version history, these sort of things. So surprisingly, actually, this is also a place where the UML diagrams make a sort of reappearance. We were drawing them earlier to design before implementation, but the class diagrams have also the other use, meaning that we gain insight into what the system actually looks like. What's probably going to change, or what we have to check when we are making changes to one part of the system. It's not a problem if we have 1,000 lines of code in a course assignment, but if we have 1 million lines of code or 10 million lines of code, like in large open source projects, then if we have to check everything after every change, then we are having a problem. Oh well, you are having a problem because I'm not doing anything. Anyway, these are the indicators that we are running into a problem. So what things we have here? The brain drain, running in emulation mode because we no longer support natively the original hardware. We have large bloated components which are doing something weird, or no one wants to be the person who completely broke the system down, so you just don't touch anything that already existed. There's different technologies because the one we used to build the original system doesn't exist anymore. This is actually very interestingly, this is most common in long-term stuff like in banking or insurance systems. There's almost always in each financial institution the one server cluster which probably doesn't do anything else than just warm up the building, but because it might do something, no one wants to be the person who shuts it down and completely destroys everything in their infrastructure. So this is the result of deficient documentation and this, probably also this, or definitely about this. So yeah, things start to accumulate. When you allow first problems into the system, you are going to have the rest of them. So none of these is actually a very good sign to have in a product you are maintaining, but still these are the indicators that something needs to be done and that something is problematic. So finally, because everything moves forward, technology moves forward, the data management, how we save our data, how we use our systems, how we actually even have shifted towards these mobile phones and cloud-based approaches or container-based services and these sort of things. It of course means that we have to maintain our stuff, because evolution in technology means that if we don't do that, then our existing software or existing services or existing applications cease to function. If we have a system that is used, it will change. That's the Lehman's third law. The first and the second were about the design aspects of the software, but this is actually important to understand. If there's users or if there's some actual use, it will inevitably need maintenance and change at some point. So, anyway, the maintenance problems, these aren't rocket science. I've mentioned this 4 times now, so you probably should now start to believe me. But anyway, the same problems as were with the software development process exist in the software maintenance process. However, now they are critical in a sense that the people no longer probably exist in the organization or at all, who originally knew something. So if you don't have documentation, if your code is unstructured mess, everything is related to something, you can't fix one thing without breaking the entire application, you are completely screwed. So these things that we try to not let happen on the development phase are now slapping you in the face when you are trying to do the maintenance work. And this is also why we are using real software projects in this course, so that you understand the scale and complexity of these problems, not just ramblings of me, who you have to trust on these things, because I'm a university professor. I have jack shit. Well, of course I know about maintaining software and have experience in completing software features and doing development work and stuff like that. But still, so that you will actually believe me, let's go check real industrial scale projects and their problems. So, from this lecture, keep in mind the definition of software lifecycle and maintenance, and also the reasons why maintenance needs to happen. We'll continue with these other topics next week. Also, go check the Moodle pages, go check the project assignments, the first teamwork assignment, and also the seminar presentation and report assignment. Form your project group, read through the instructions, reserve your project topic, the seminar project topic that is, and start the teamwork project. It's not that hard to do. I'd say that each one of you can get the 1-point solution done in one evening, but you might want to try for the 6-point solution, because it's not that difficult really. But anyway, go check out the Moodle pages, go read through the stuff there, and remember that there are no exercise events on Fridays, even if your uni scheduler says so. And the first Moodle assignments, the weekly assignments, are available next week after the second lecture on next Monday. So don't worry if you don't find any of those things online yet. Okay, good. that's that. And I'll end the recording now, and you can ask questions or come here to ask me stuff if something worries you after I have ended the recording.